Section 7.2 Trigonometric Integrals. A trigonometric integral is an integral whose integrand contains powers of one or more trigonometric functions. Okay, such as this. When m and n are non-negative integers. There are cases. So there are techniques for each cases. For case 1, if n is an odd positive integer, then you use the cosine square x is equal to 1 minus sine square x to express the remaining expression in terms of the sign, like this. Then this original integration can be rewritten in this way. So if you substitute the sine x as u, then dx du can be written as cosine x du. So integration by part will be used in this process of integration. Here is the example. If you have the n is a odd positive integer, then let u is equal to sine x, then du is equal to cosine x dx. So this integration can be written in this way. With u, this can be simply written in this way, which is a very easy integrations, which can be obtained like this. But if m is the odd positive integer, if m is the odd positive integer, then this substitution, sine square x is equal to 1 minus cosine square x, should be used to make it simple. Okay? If m and n are both even positive integers, then this substitution, sine square x is equal to 1/2 1 minus cosine 2x, cosine square x is equal to 1/2 times 1 plus cosine 2x. 이 두 배가 공식이죠. This should be used like you see here. This can be written in this way, then this can be easily calculated. This one too. For this case, half angle formula. Half angle formula can be used to make it simplified, which gives us a very easy integration. And if n is an even, so integral tangent m's power times secant n's power dx, then there are cases. 1, n is an even positive integer, then you use this substitution. And then let u be tangent x. Then it will make all easy, like you see here. Then let secant square x is 1 plus tangent square x, and let u be a tangent x, then du can be written here. So this can be simplified like this, which is going to be a very easy integration. If m is an odd positive number, then this substitution should be used. And let u be the secant x. Okay, like this, which make this integration to be this simple form to get the answers like this. Okay, from there you can deduce a formula that you are familiar with. This is one special case of the above integration. Evaluate fifth power of tangent x dx, and you separate it in this way, and then for this one you just simplify once more. You just simplify it like this, then use the arctangent of x like this. So there are a whole bunch of case 3 if m is this is not ever, this is even. Okay, case 3 is if m is an even integer and n is an odd positive integer, then this substitution works and express the remaining factors in terms of secant x, like this. Tangent square x can be replaced with this, and then let the secant x, then the important part is the integration of secant x. That makes all the rest easy. And for the other case, then sometimes you have to use the 1 plus cotangent square x as a cosecant square x dx integration, and a whole bunch of things. Okay. For the integrations of those, sine mx, cosine nx, sine mx, sine nx, cosine mx, cosine nx. To do this, you need to use the following trigonometric identities. So it's getting more involved. Here is the one example. Finding it, just use those substitutions to make it a little simpler than before. Like this. I have given you the problems to solve, so you may do exercise it in a way of your choice. I will give you a chance to present your solutions on section 7.2. Any questions?